Our phones recognize our faces. Cars can steer themselves. Machines translate languages instantly. This isn't magic, it's the power of deep learning, a form of artificial intelligence quietly transforming our world. Hidden within our devices are complex algorithms that mimic the human brain, enabling machines to learn from experience and make decisions like never before. Deep learning isn't about programming explicit rules. Instead, we feed vast amounts of data into artificial neural networks, intricate structures inspired by the human brain. These networks, through a process of trial and error, learn to identify patterns and make predictions, constantly refining their understanding. This revolutionary technology is changing how we interact with the world. From medical diagnoses to personalized recommendations, deep learning is driving a new era of intelligent machines capable of understanding and responding to our needs. Deep learning's power lies in its ability to learn like we do. Just as our brains form connections through experience, deep learning algorithms adjust themselves based on the data they receive. Imagine a child learning to recognize a cat. They don't memorize a checklist of features, they learn from seeing numerous examples. Deep learning operates similarly. By processing vast datasets of images, sounds, or text, these algorithms learn to distinguish subtle patterns and make connections, much like our own brains. This ability to learn from raw data without explicit instructions is what makes deep learning so powerful and adaptable. This approach mirrors the human brain's process of learning through observation and repetition. The more data these networks process, the more refined their understanding becomes, allowing them to tackle increasingly complex tasks. Imagine a neural network as a multi-layered web. Data enters the input layer, like information entering our senses. It then travels through hidden layers where complex processing occurs, much like our brains analyze information. Finally, the processed information emerges from the output layer as a decision or prediction. Each connection within this network is a synapse, a pathway for information to flow. These connections have weights, determining the strength of the signal. Think of them as volume knobs, amplifying or diminishing the importance of specific information. As data flows through these interconnected neurons, the network adjusts its weights and biases, refining its understanding of the relationships within the data. This constant adaptation allows the network to learn and improve its performance over time. Crucially, deep learning algorithms learn from their mistakes. This process, called backpropagation, is, well, kind of like us learning from feedback. Imagine you're learning to ride a bike. Each wobble, each near fall, provides valuable information. Similarly, when a neural network makes an inaccurate prediction, the error is calculated and fed back through the network. This feedback adjusts the weights and biases of the connections, making the network more likely to make accurate predictions in the future. This iterative process of trial and error, of making predictions and learning from mistakes, is really at the heart of how deep learning algorithms become increasingly accurate and sophisticated in their understanding. The true power of deep learning lies in its ability to find patterns hidden within data, patterns that might remain invisible to even the most astute human observer. By analyzing vast datasets, these algorithms can identify subtle correlations and trends, revealing insights that would otherwise remain hidden. This capability has far-reaching implications. In healthcare, deep learning algorithms can analyze medical images to detect diseases at their earliest stages. In finance, they can identify fraudulent transactions with remarkable accuracy. And in self-driving cars, they enable vehicles to navigate complex environments. This ability to uncover hidden patterns is, honestly, revolutionizing entire industries, leading to breakthroughs in scientific discovery, business optimization, and our understanding of the world around us. Just as the human brain has specialized regions, different types of deep learning networks are tailored for specific tasks. Convolutional neural networks, or CNNs, excel at image recognition, their design inspired by the visual cortex. They power everything from facial recognition software to self-driving cars. Recurrent neural networks, or RNNs, on the other hand, are designed to process sequences of data, making them ideal for tasks like language translation and speech recognition. They can analyze patterns over time, understanding the context and meaning within a sequence of words or sounds. Transformers, a more recent breakthrough, excel at natural language processing tasks. They analyze relationships between words in a sentence, enabling them to generate coherent and contextually relevant text, powering chatbots and language translation tools. Deep learning is not merely a technological advancement, it represents a fundamental shift in how machines understand and interact with the world. By mimicking the human brain's ability to learn from experience, we're, creating a new generation of intelligent machines. These machines can analyze complex data, make predictions, and even exhibit creativity. They're helping us solve some of humanity's most pressing problems, from diagnosing diseases to developing new forms of renewable energy. As deep learning continues to evolve, it promises to reshape our world in profound ways, leading to a future where humans and intelligent machines work together to build a brighter future.